Let's welcome now Philippa Gill, a research scientist at Google. She will talk about the M-Lab project.
Oh, shoot. Is there a dongle? I thought this had HDMI, but it doesn't.
Doesn't?
Is there a HDMI?
Yeah.
Oh, I mean, like a dongle?
Oh, I don't know.
Sorry.
Yes.
Sorry, I thought this had it, but it doesn't.
Ah, no worries. Oh.
Thank you.
Okay.
All right. Thank you, everyone, for staying here till the last talk of the day. Today, I'm going to be talking about Measurement Lab. I'm going to be talking about what we do, how you can work with our data, and hopefully how we can collaborate to improve network measurement. Measurement Lab was founded back in 2009 as a consortium between Open Technology Institute, Planet Lab, Google, as well as academic researchers. It was spurred on by a challenge that researchers were facing with a lack of widely deployed, well-connected servers for active measurements, as well as challenges with sharing open data sets. So if you were doing network measurement at this time, you might remember that Planet Lab was actually the most popular platform for measurements. And if you ever tried to use it before the SIGCOMM or IMC deadline, you know that resource contention was a problem. One thing I want to acknowledge is that a lot has changed since 2009. Since then, cloud computing has become widely available. It's a lot easier for researchers to deploy servers around the globe. And one of the things that I'd love to hear from folks and talk to you guys later on or tomorrow is, what are the challenges facing network measurement, and how can Measurement Lab best help researchers today? Okay, since its starting, Measurement Lab has grown into a large open source project. It's got contributors from civil society, educational institutions, as well as private sector companies. In 2019, it shifted from the Open Technology Institute to Code for Science and Society. This is a nonprofit organization, so Measurement Lab is actually a part of Code for Science and Society. Google contributes software engineering resources as well as financial resources. But Measurement Lab itself is actually external. It's dedicated to providing an open measurement platform that is verifiable and providing global network performance data. We do this through open source measurement, so the code is all open. You can go, you can verify what it's doing. And we provide a large, reliable platform of physical servers around the world. We also host the largest open data set about internet performance. So this is referring to our throughput data. And this is really complementary to other large open data sets like CADA or RIPE Atlas. And finally, Measurement Lab isn't just serving academics. They spend a lot of time working with legislators and policymakers. And this leads to them spending time creating visualizations and helping people make sense of the data that's coming out of the platform. The dataset offers a uniquely comprehensive view of the internet's health, both today as well as in the past, and it's set up to do highly targeted, comparable, and longitudinal measurements. And I really want to stress the longitudinal aspect here, coming from being a former academic. You know what happens when your PhD student graduates. Keeping the measurement platform going is very challenging. It's also challenging to get funding for ongoing measurement work. This is something that Measurement Lab is very good at, so we're keen to help with these types of challenges. Okay, Measurement Lab's mission is basically to measure the internet, save the data, making it universally accessible and, importantly, useful. And I hope by the end of this talk you see how you can help by collaborating with us, using our data, and working together to measure the internet. So I'm just going to go through how Measurement Lab is used. We have a variety of people using our platform and data. The first is end users. So if you go to Google and you say, how fast is my internet? That speed test that pops up, that's us. It returns to the user the throughput, the latency, and loss of their connection. So this helps users understand their network connectivity. The speed test is also integrated into other websites and products. So Consumer Reports has the Measuring Broadband Together project, where basically people can perform an NDT test, fill out some survey questions, and then Consumer Reports is analyzing the data. There's also Fingbox, which is a little hardware device that helps people monitor their networks, and NDT is used to help them monitor their network throughput. And finally, Airbnb hosts can actually test their throughput, and then they have a mechanism to post the measurement to their Airbnb listing. So you want to go work remotely in the mountains, it gives you a way to know if you'll have enough throughput for all the video conferencing. M-Lab also works with regulators. They do this through a variety of ways. One is local data collection. There's the Murakami open source project. This allows people to put Measurement Lab software onto Raspberry Pis, so you can distribute Measurement Lab clients around and do ongoing measurements. This is what the Internet Society did with the Measuring Internet Resilience in Africa campaign. Our data is also used in a variety of broadband mapping efforts, so the NTIA in the US, as well as the EU, use our data to create maps of broadband connectivity. And finally, this last set, most relevant to us, academics. We host third-party measurement services. If you have a measurement service you're thinking about running on the platform, this is something that we do. Two notable ones for our community are Reverse Traceroute and WIHI. These have both appeared at NSDI, IMC, and SIGCOMM'. The data has also been used in networking course projects. So some students in Justine Sherry's networking course actually analyzed NDT data, and now all of us have an IMC paper coming up, so that was kind of nice. And finally, academics completely separate from us are using our data. There was actually an IMC paper last year using our traceroute data to map broadband access networks. Okay, so this is a lot of different applications and consumers. How do we do all this? We're a growing consortium. Currently, we're Code for Science and Society and Google. We have some exciting new collaborations coming up, so we're working with Cloudflare, EdgeNet, and I want to highlight this box right here. If anyone has an organization and is interested, we are really eager to grow this consortium, so please come find me, send me an email. I'm definitely interested in talking. Okay, to give you an overview of the M-Lab ecosystem, we have our physical platform of servers around the world. We have our ongoing data collection with the NDT speed test. We have our public data, which is all archived in BigQuery. We have third-party hosting for all your active measurement needs. And finally, all of the code is open source on GitHub. Okay, so just to give you an overview of the platform, the overall architecture is on the slide here. It starts with client integration, so this could be your browser if you're running a speed test, or your WIHI app if you're using WIHI. The request comes to our locate service, which is basically a load balancer that directs clients to the servers that are geographically closest to them. And once the client connects to the server, it'll connect to whichever measurement service it's wanting to connect to, so NDT or WIHI. A measurement is performed. The data is then pushed into Google Cloud Storage, and depending on the data source, so our data makes it to BigQuery. We're working on getting the measurement service data also in BigQuery. And this was actually the subject of a tutorial on Monday. I'll post a link to the tutorial slides and exercises in the Slack channel for this session if folks want to take a look. Okay. This is our physical infrastructure, so it's 500 plus servers in 130 different metros globally. Traditionally, the Measurement Lab sites were chosen to be in transit ISPs, so this means a lot of our tests basically cross at least one interdomain boundary. One thing that we're revisiting is the type of paths we measure and thinking about what paths are more relevant to content that people are accessing. So we started adding some servers in the cloud. We're interested in expanding to different cloud providers. So if anyone is a cloud provider and is interested in hosting servers, again, please come talk to me. Zooming in on one of those metro locations. So the metro basically has servers. The servers are in groups of 4. So 3 of these are production, 1 is for testing. And each of these groups of 4 is what we call a site, and each site connects to a different transit network. So this gives you the ability to measure to the same geographic location, but with different transit connectivity. So you can imagine the different experiments this can enable, as well as the different analysis you could do of the data we're already gathering. So just to give you a quick overview of the data, again, I encourage you guys to check out the tutorial materials for more detail. We have a lot of data publicly archived and accessible in BigQuery. This is all free. You don't need me to do anything. You can access it yourself. Our main data set is the NDT test results. So this is our speed test, giving throughput. We also have trace routes, packet captures, and TCP info snapshots for each test. And we're working on getting data from the third-party measurement services into BigQuery, but it's all currently there in a GCS storage bucket. Okay, to give just a quick bit of info about the NDT data, so the test has been running for just over a decade now. We hit 3 billion rows in 2021. Most of this data is coming from that Google search integration, and we get about 3 million tests per day. Most of the tests are using the BBR congestion control algorithm. We still have a small amount of tests using Cubic, as well as a lot of historical data using Cubic. Okay, and again, as I've said, and I will say again, all this open, publicly available. You know, it's one line of BigQuery, very easy to work with. So what's next for M-Lab? You know, we're interested in hosting more third-party services. We have capacity for it. All these servers are running identical software. It's managed with Kubernetes using containerized services. The focus is on client-initiated experiments, so clients measure against these servers. If you run a measurement on our server, you get what we call sidecar services for free, so you can have packet captures, TCP info snapshots, and traceroute data gathered alongside your measurement. If you have an IRB approval that says you can't gather the client's IP address, you can also opt out of these as needed. So, you know, in principle, we can support 10 to 12 IPv4 experiments. We're running about 4 right now, so lots of space for more measurements. We're also interested in collaborating on research. There's a lot of open questions with our data and ways that we could make it better. So thinking about better diagnostics. So instead of just telling someone your throughput is 100 megabits per second, tell them your throughput is 100 megabits per second and your Wi-Fi link is probably the bottleneck, or maybe you should buy a faster speed plan from your ISP. There's also interesting questions about network reliability that we can answer. So we have this ongoing signal of throughput, latency, and loss from all of these tests. And any change in this might signal that something is happening on the internet. And I've put one example on the slide here. This is kind of one of my favorite things that we've seen so far, which was that Facebook outage last fall. We saw a huge spike in the number of NDT tests. So when people think their network is down, they perform tests. So it's kind of an interesting meta signal of network availability. We're also interested in representativeness of our data, understanding, you know, how well the paths we measure capture paths towards content, as well as understanding the client populations. You know, a lot of crowdsourced data, people tend to test when things are going badly. We do have some folks doing ongoing measurements though, so trying to find these different populations and use this to better understand connectivity, you know, for specific populations. Okay, so just to wrap up, we're eager to collaborate. There's funding opportunities. In fall 2021, we had our first round of M-Lab fellowships, which were funded by the Internet Society. There's also the Google Research Scholars Program, if you have ideas to use our data that are maybe relevant to Google. We're interested in hosting new measurement services. We also have the Measurement Lab blog, so if you've written a paper using our data and you want to let people know about it, we're eager to have guest posts, you know, so you can let our community know about what you've been up to. And finally, you know, I think there's a real opportunity here to use this data more in networking courses. So you can imagine having data analysis exercises where students work with throughput data. You know, they can plot all these stats for their own ISPs very easily. You know, we can do course projects like what we did with Justine's class. And you know, obviously, if you're interested in joining the consortium, please come talk to me. And with that, I will wrap up and take any questions.
Thank you very much. Any question?
I have a quick question. Thanks, Philippa, and thanks, M-Lab, for doing this. So you said that one of the goals would be to have longitudinal data. So if you have my grad student that will do his research, but then M-Lab could keep it up. But then you showed a list of all these retired measurement tools that you had in the past, and they didn't stick for longer term. So I'm just wondering, like, I understand it's a big effort to keeping up some of these older tools. So what makes the cut? Like, how do you decide which tools that you think should stay and you M-Lab should support for longer term versus the ones that you just decide to retire? Thank you.
Yeah, I think it's a combination of having, a partner on the outside who's interested. So, for example, with WeHe, I think Dave periodically has an undergrad who can maintain it, but there's at least someone there from the original team who's still interested in the data. The methodology is still interesting. So I think like if technology changes or the measurement method is maybe no longer valid for whatever reason, that might be one reason to cycle things out. But I think definitely it's worth, periodically revisiting what's running. But like if data is relevant, especially, for example, the WeHe data, which tells us things about traffic differentiation, net neutrality, we're really eager to try to get that into BigQuery because maybe it's, you can only write so many SIGCOMM papers saying T-Mobile is rate limiting traffic. But possibly this data is interesting to policymakers. So, helping these technical services, bubble up the data into more usable ways.
Thanks for the great talk here. This is Stefanos from University of Glasgow. I was wondering if you have any measurements about the errors introduced between where the client initiates the measurement and the location that the measurement takes place, like the server side. Are there any data about the errors introduced in that path, and whether this data could be used to generalize and say approximate like measurements instead of actually doing them?
I'm sorry, I didn't quite catch the question.
So do you have any data related to the errors introduced in the measurement process between where the measurement is initiated and the location of the server that does the measurement?
Oh, like if there was a middle box or something tampering with. So this is interesting. I've thought about looking at this. I used to do a lot of work on censorship measurement. Since we have packet captures for all of our tests, we could actually go through and look for signatures of injected packets. It would require there's a sensor or middle box interested enough in impacting our results. There's also things we can look for like TOS bits in the IP header to see if maybe there's prioritization of the traffic or things like that. But we don't have a sense that any of that's happening right now, but it's on our radar to look at.
Thank you.
We have a question from Slack. Is NDT able to derive what last mile technology a client test was run for?
We're working on it. Okay. So we don't have a solution at this point. I have an intern that's working with me doing some data analysis of our, we have this giant blob of data, and can we figure out, groups of tests that maybe have similar network conditions?
Yeah, thank you, Henning Schutzoni again. I obviously had some connections to M-Lab in a previous job. So I'm curious, you talked about reliability, and that's clearly a concern of many these days, but the convenience sample model doesn't seem to lend itself well to reliability. So I wonder, you mentioned that you have like a permanent kind of background testing. How large a set of people, how geographic, how well does it represent different carriers like in different countries? I mean, how useful is this truly to get a sense of which carriers or technologies are more reliable than others?
Yeah, I mean, so right now the bulk of our data is coming from, the Google speed test, which tends to be frustrated people, which is obviously not what we would like. But we are working on trying to find ways to get more kind of ongoing measurements out there and get that baseline. I don't think we have a perfect baseline right now. I think some people are using the platform to measure a baseline, so we might be able to extract that. But I think it's definitely something that we would like to do more.
You alluded to, I mean, in order to get information about locations and carriers, you obviously need the IP address at least of the client side, which raises privacy concerns. So could you say a little bit more as to, so you basically, before you release the IP address data of the client as part of a measurement data, you have to get IRB approval, or what's the relationship? You mentioned something, but it kind of blew past me.
Yeah, so the NDT data right now does include the client IP address. This is something that we're revisiting with our community, possibly putting it behind some sort of access control list. Removing the IP address, like so for example, WeHe has an IRB approval where they don't store the client IP address. So for them, we turn off packet captures or TCP info or any of those services that would publish potentially the client IP. For NDT, we currently do. It's difficult because it's hard when you've given someone a bit of data and then you want to take it away. So like the IMC 2021 paper that I pointed at actually leverages the fact that we have data right down to the client IP to do their access network mapping. So it's, yeah, it's something on our radar for sure.
Thank you.
Time for last question.
Sanjay from Purdue. Thanks for the service. So you mentioned that we could do our own measurement services. So what's the process for that? Do we have to propose something and get it approved? What are the rules and guidelines you'll be looking for if we were to propose a measurement?
Yeah, so there's a process to submit a proposal. It involved contacting our friends at Code for Science and Society, and then there's the Experiment Review Committee, which is a lot of people who are originally on the project. You know, some constraints, like I mentioned, it's tending towards client-initiated active measurements. So, you know, if the experiment is to have these servers like trace route out to a bunch of prefixes, that's not really the type of thing we're interested in. But, you know, happy to talk in more detail.
Okay, thank you.
Then thank you very much, and thanks for the service.